have service co-robots that we could bring into our homes. These would be fairly affordable. Every family could own one. But when it comes to kind of what we have existing in terms of conventional robotics, I mean, the idea like this is like, something like this would be like terrifying, right? And for the most part, I mean, yeah, robotics has not delivered on this promise of service robots, but it certainly has done extraordinary things in an industrial workspace. Okay, so the idea here is, what do we need to do engineering-wise to get from this to something like this, right? Where we could have robots in our homes, hospitals, schools. And kind of from a mechanics perspective, what I see is a really kind of big challenge, and this is kind of not just from a robotics and application standpoint, but more of like even a scientific or intellectual challenge, is how do we kind of re-engineer our robots and machines using a completely different set of materials, and in particular, materials that are on a completely different end of the spectrum when it comes to Young's modulus. Okay, so Young's modulus is just kind of one metric, one measure of the elastic rigidity of a material, and even for Young's modulus, we know that this is a fairly limited definition, right? I mean, Young's modulus scales with the amount of force it takes to stretch a material, and it's fairly linear when it comes to very small strains. Okay, strains in the order of, say, fractions of a percent. But when we talk about soft robotics or soft biologically inspired type machines and systems, it's quite possible that we're going to be seeing strains well outside of this linearized regime where Hooke's law is applicable, right? So we have to kind of be a little bit kind of more careful about the types of constitutive properties and the theories that we use to examine these classes of materials and machines. Okay, so Hooke's law is fine for kind of conventional, more rigid materials, hard plastics, metals. But a lot of the work that we do in my lab is in addition